Lead software engineer here at Tracetest. Today, I'm going to be showing you how you can enhance your performance testing using K6 by including trace-based testing with Tracetest. So the use case that we have here today is one of our Pokeshop Demo services, which is including a Pokemon by ID. So this service has two different sections, two main sections. The first one is the initial post request to this specific service /Pokemon/Pokemon/ import, and then we have a span to validate the request that the ID exists, is part of the request, that kind of stuff. And then we're putting a message into RabbitMQ, which is going to be then handled by the worker, which executes these four processes, that is checking the memory database that is Redis to if it exists. If it doesn't exist, we go to the Poke API service to grab the information for the Pokemon. And then we save that data to both Postgres and Redis to not look at it from the Poke API again. So this is a pretty common scenario where we have an initial request and we have an asynchronous process, and where the initial request just returns kind of an echo saying, hey, we're processing this is accepted, but there's the background process is being executed asynchronously. So to start, we're going to be executing a script which if triggers the request that we need to that service. So this is a K6 script, which uses the regular HTTP libraries, the sleep and check. And also what it does is it triggers a request to our service that is /Pokemon/import using the Pokemon ID that we specified over here, that is Charizard. We also do have two checks. One of them is if the service returns 200, the status is 200, and the body matches the ID. So the ID that we send is the same one that is returned to us after the request is processed. So if I run this, let's go to our terminal and try to run this. So if I run this by the regular K6 binary, it's going to be executed. We're going to see the status is 200 and the body matches the ID, everything is correct. So what happens if the worker just stops running? It dies, there's a problem, there's a connectivity issue, something like that. And we want to validate that the whole process is working correctly. So if we go back and I go to the Docker instance, the Docker app, and then I stop the worker, and then I try to go back to the terminal and trigger the same tests. Let's say trigger the same test. Even if the worker is not running, stop, I will continue seeing the same result. So the status still 200 and the body still matches the ID. So sadly, performance tests that are against the front-facing service cannot catch this type of problems, type of errors. That's where Tracetest comes into play, where we can not only test the initial trigger request, but also and response, but also whatever the tracing data that's generated by the whole process. So if we go back to our script, we're going to be copying this that I have over here, which includes everything regarding the Tracetest information and the Tracetest extension. So we're using the HTTP and Tracetest objects from our binary, from the combined library. We are specifying a test ID, and then we have the similar approach where we trigger the post request, but in this case we also do a Tracetest run test in this case to generate the tests, the runs in the Tracetest server. So first I'm going to be looking at the test I'm going to be creating. This is a test definition from Tracetest, and we have some specs that are going to be checking the critical parts of the process. We're going to be grabbing the span type called import Pokemon, and this needs to exist. So we're checking that at least one span exists. And the second one is we're grabbing the database span that creates and adds the Pokemon to the database. And we're going to be checking that it uses the name of Charizard because of the Pokemon that we're trying to import. So to do this, I'm going to be using the Tracetest CLI to create this specific tests. As you can see, it is over here. If I go to my test list, I will see K6 over here, so it exists already. And the next thing is just triggering the specific test script. So if we go back to the terminal and then we go here and execute it, now as you can see, we're adding a new thing that is the token. So we have a token that we generate from the Tracetest application, and then we are using our output that is called K6 Tracetest. Immediately, we're going to see a couple of differences. And the first thing is that it's going to take a little bit longer because it's trying to fetch and wait for the spans to be generated and placed into the tracing backend that we use, that is Jaeger. And then at the end, we're going to be looking at the different results and summary for every test that were executed. Now, what we can see here is that as part of the summary, total runs, we have 6. None of them succeed, and 6 of them fail. And if we go and follow this link that we have over here, we're going to know why. So if we go to test, of course, our assertions fail because the second half of the worker is not running. So this catches those sort of problems that are asynchronous. So you go back to Docker, and then we start the worker, and then we run the script once more. We're going to be seeing that everything will be passing now. So we just wait a couple of seconds until it finishes executing. We are going to be expecting to have a summary similar to this, but with total runs being a similar number, but everything passing instead of the all failure that we see to it here. Okay, so now it's not panicking. It means that everything succeed, and as you can see, the 6 successful runs. If we follow this link again, we're going to find out that no, my internet is a little bit slow. Sorry. So we're going to find out that all of the specs are passing. So the second half of the trace is over here after the queue and the worker, and the assertions that we have over here are passing as well. So yes, kind of in hindsight, this is combining the performance testing with K6 and Tracetest enables you to kind of have a deeper look at the entire process, asynchronous process on the whole system, how it behaves, how it communicates between different pieces, and not only that, but also assert into any of the specific spans or generated telemetry data from that service or from that process. Thank you for watching. Until next time.